Alright, so in this video we're going to talk about finding the slope of a distance versus time graph. And now really this will work with any type of graph, but right now we're focused on distance versus time graphs. So we're going to focus on an example that has a distance versus time. So now just some general information. So slope is the measure of the steepness of a line. And so when we say steepness, it's how quickly it's increasing. So if you think of a really steep hill, right, then it's a lot more effort to go up. It's almost vertical, or approaching vertical. Or if you think of a very gradual hill that's not steep, there's not much of an incline. That's not going up by very much. So we can find slope, so it can be found by taking the rise divided by the run, or rise over run is sometimes how you'll hear it. So specifically the rise is the difference between two y points, so the vertical ones, and the run is the difference between two x points, or the horizontal ones. So again, we have the y here, and that's the vertical, and we have the x, and that's this horizontal. And so now we're looking at the change, and that's kind of that point. So we'll pick 2 points on our line, and then we find the difference between them. Now in this particular image, we actually have some points that are negative, which is fine. It just can change the difference. So if we're truly looking, we have a -2, and we have a 4 for our x. So then if we have 4 and a -2, well, the difference is going to be 6, right? Because you got to go 1, 2 before we get to 0, and then we got the next 4. And then now if we're looking, we have 3 and we have -1, which is going to be 4, because again we have to go to 0, which is 1, and then 1, 2, 3. And so then that would really give us a y change of 4, and then that'll give us an x change of 6, right? So then we could find the slope of this line, and that's what we're looking at. And you guys are familiar with this kind of triangle you make. Another way you could kind of think about it, and I'm going to teach you guys using the points because I think that's the easiest and most consistent way. But you kind of think about it, okay, so if I draw a line off here and off here, the point where they intersect is going to kind of tell me that change, and then I still have to look at the points, you still have to know them, but that's sometimes the way that makes sense. We're looking basically where they intersect, and that's the way to how far. We're just finding then now the length of this line. Okay? Alright, so let's look at an example. So we want to find the slope of this line here. We have a distance meters, and we have a time seconds. So right away we know that this line is telling us the speed of person A. Now we don't know what they're doing, we just know we have a graph of person A and they're moving, and we know that they're at a constant speed because this is a straight line. Again, we know it's speed because we have distance and we have time, right? Because the two things we need for speed are distance and time. If we have those two things, then right away we know, oh, we're finding speed. Okay, so step 1, pick 2 points on the line. So we can pick any 2 points here. Now let's just say we have these points here that we've picked. Okay, and so now the tip I kind of gave you here as well is have them line up with the grid lines. It's really helpful. I mean, technically you don't have to. There could be a point here, there could be a point there, right, if we're not giving them. But this makes it so much easier if we do that, because then when we ultimately figure out that change, we have exact numbers that we can look at on our axes, and then we're not guessing as to what it actually is. So this is really the best way to go, and what I would really ask you to do. Alright, so our next step, so step 2, is going to be identify the coordinates of each point in XY format, right? So we use those kind of XY coordinates that we've kind of been taught already. And so then if we do that, we should end up, well, if we do that, so we'll find the points for this, the coordinates for this dot and the coordinates for this dot here. So then that way we'll end up with 2 and 4, and 4 and 8 for points. So then our 2 is our x, and our 4 is our x, and this 4 is our x, and this 8 is our, or sorry, this 4 is our y, and this 8 is our y. So it's always x, then y. Alright, so our step 3, subtract the x value from each other and subtract the y values from each other. Oh, there's actually a little typo there. Let me go ahead and fix that. This should really be values. There we go. Let's just fix that. Okay. So we're going to subtract the x values from each other, and that's going to find us our run. And we'll subtract our y values from each other. That's going to find our rise. Okay, so we've done that. So we have our run 4 minus 2, which gives us 2. We have our rise, which is 8, minus 4, which gives us 4. Again, so this 4, all right, is coming from here. And then the 2 is coming from here for our run. Now for our rise, our 8 is coming from here, and our 4 is coming from here, and we subtract those, ultimately finding the difference between those points. All right, now we're on step 4, and it's going to be find the slope. So again, rise over run. So now we're actually at the point where we're actually finding the slope. And so if we do that, we end up with our 4 divided by our 2, and again, we have that 4 coming from here, and we have that 2 coming from here, and then we divide them, and we get our answer of 2. Now you might think we're done, but we're not quite. There's another step that we gotta take. All right, so that next step then, so step 5 is going to place the correct unit on answer. So we need to make sure that this has the correct unit. Right now, we don't have anything on here, and we need to make sure that we do. And specifically because we have a distance and time graph. So one hint that I will give you as to what that unit might be is by circling these points over here. So I have distance, right, and I have time. Well, our unit then is going to be a combination of those. We plotted both of those things. We plotted a point for time and you plotted a point for that distance. So our unit should be a combination of those two. And now in class, I talked about, think of an alligator or crocodile, in which, say, this is the top part of the mouth and this is the bottom part of the mouth. And then if we have, say, meters here and it goes, you know, snaps down on top of this one here, right? So pretend it goes, boom, bam, and snaps down. Then what kind of ends up happening is we get this meter falling down on top of the seconds, which kind of tells us what our unit is. We should end up with meters per second, right? So this meters is essentially on top of the seconds. This is just written kind of in the sideways version, but you could also think of it, right? So if we took this and took that same analogy of this kind of collapsing down on top, right? So if it's like, whoa, then we should end up, right, with our meters over our seconds. And that's, you know, what we got down in this corner, which is a different way of writing it. And so that's how we come up with that unit. So now if I had a difference, say this time was instead of seconds, say it was minutes, then it's going to be meters per minute instead of meters per second like we have here. Or if this distance is kilometers, then kilometers per second, which would be really fast, by the way. That's how we find that unit. You can really use that with any graph, especially those distance versus time graphs. And that wraps up our video on calculating slope. If you do have questions, please come talk to me in class. Hopefully this video helped you better understand how to find slope and where we get those units in our distance versus time graphs.